Now we want to talk about something that's sort of interesting. It's concavity. So we'll be given graph of a function, and we'll be asked to find the regions or the intervals that are concave up or concave down. So these answers will be intervals. And then there's one more thing they'll ask about. You'll be asked to determine any points of inflection. So this on the graph will be a point, and I'll explain in a minute, but basically if the graph changes from concave up to concave down, the point at where it changes is called a point of inflection, or the graph could go from concave down to concave up. So the point of inflection is where the concavity changes. Now, what's interesting is concavity is sort of like the slope a little bit in that it's a concept, but it also is actually a number. Turns out concave up, well, let's hold off on that. That's something more that we will get in depth to during calculus class, but for now, let's just say that, yeah, looking at graphs, concave up and concave down. So let's talk about concave up. Concave up is in the graph when the graph looks like a bowl. Say I have the graph of a parabola. This whole graph looks like a bowl. Sometimes people like to say the graph opens up, right? Opens up. So the curvature of the graph, it opens up. Now you compare it concave down. It's like this, concave down. I usually say it's like you have an umbrella. Some people like to think that it opens down. So the curvature is sort of down. The ends of the graph are going down. Here, the ends of the graph are going up. So if we were to ask, please give the intervals where the graph is concave up or concave down. For this one, the whole graph would be concave up and concave down. Let me give you one where for the same graph, the concavity changes. So how about so once again, concavity is something you sort of start at the left hand of the graph, And as you move toward the right, you sort of ask yourself, is this like, am I tracing out sort of like a bowl or a cup, or is it like an umbrella? And hopefully you can see here, the curve of this line is sort of like the side of a bowl. It's opening up. And right here, it's like a bowl, right? It's like a bowl. Now, what's interesting is I keep going, and then by the time I get like over in here, I notice it's not like a bowl anymore, because now it feels like it's sort of like I'm at the top of an umbrella. So here, it definitely feels like it's concave up. But then once I get to here, especially when I get over in here, it's definitely like an umbrella. So this part of the graph is definitely concave down. So hopefully you can sort of see what I'm talking about. This graph starts out as concave up. You can imagine this is almost like a bowl. But if it was a bowl, it would keep going like this. But what does this do? Instead of continuing to be concave up, all of a sudden it turns around and it's like an umbrella. So what happened? The concavity between here and here, it changed from concave up to concave down. Now, what's interesting is, where did it switch? Oftentimes, you cannot necessarily on a graph or with the naked eye point to the exact place, because it's very subtle, right? Because it's sort of concave up, the curvature is up, and then somewhere in here, very subtly, it switches from sort of curving up. Next thing you know, it's starting to curve down. So somewhere in here, and it's not always easy to tell, would be our point of inflection. The point of inflection is the point at which the concavity changed from concave up to concave down. Let me do one more sort of example by hand, and then we'll look at some graphs printed out. So if you're given this graph, you're asked, where is the graph concave up? Where is it concave down? And are there any points of inflection? And approximately where are the points of inflection? So if we start here, what do we got going on here? Is this sort of like tracing out sort of like an umbrella, or is it like a bowl or a cup? Well, definitely an umbrella. So it's like concave down, concave down, concave down. But then as I get over here, I'm saying, whoops, this is like a bowl, right? So now all of a sudden here, it becomes concave up. So here, was definitely concave down. By the time I get over here, it's concave up. Somewhere, the concavity flipped or switched. And, once again, you can sort of say it's like an umbrella, or it's like a bowl. Where did it switch? Probably in there somewhere. And what's going to happen in calculus, there are going to be mathematical ways to determine, because a point of inflection is exactly one point. But what I'm saying is, when you look at a graph with your naked eye, you can't really tell exactly where the concavity changes. there is a point where it does change, and you can find out that exact point, but you have to do it mathematically, which we will end up doing in calculus. All we can say now, the graph is there is a point of inflection. It's probably somewhere in here, but we can't really quite pick out the exact place. All right, so hopefully that's clear. So that's why, we would say in a sense, this would be the interval of concave down, and this would be the interval concave up. And even to write the intervals is going to be hard. Let's just say we actually realize that the point of inflection occurs when x is 1. Then we could say it's concave down so this goes on forever and ever, negative infinity to 1. That's where it's concave down. And it's concave up. Where is it like sort of a bowl? Well, it starts here at 1, when x is 1, and it goes to infinity. But the key is to give the intervals of concave up and concave down. You have to really know the exact point of inflection. So when you look at some of these graphs, once again, with looking at a graph, normally you cannot exactly determine the point of inflection. So these graphs, we just may sort of, in general, sort of summarize what's going on. And we might not even be able to write out the exact intervals. To do the exact intervals, you have to do some calculus to find the exact point of inflection. So for instance, if we look at this graph, maybe the question we want to answer is just basically, in a general terms, where is the graph concave up? Where is it concave down? And are there any points of inflection? Well, this one, hopefully it's pretty obvious. This whole thing is concave up. And because the concavity never does change or switch, there's no point of inflection. So here, actually, we could give the interval, and it would just be negative infinity to infinity. Concave up from negative infinity to infinity. So here, as we start out, looks like concave down, right? Sort of opens down, it's sort of like an umbrella. Still concave down, but now we sort of keep going and we're thinking it's concave down, but then I get to here and I say, oops, now it feels like it's starting to curve sort of upward. By the time I get down here, it's definitely concave up. And then it's concave up to the end. So it looks like it's concave down, definitely here. This part, it's concave up, and somewhere in the middle it changed. And here's a good example, because you can see how it's sort of curving down here. And then somewhere in here, very subtly, you almost can't even see it, it starts to curve up. Where exactly does it switch? It's really hard to tell with the naked eye. You actually have to go in and mathematically figure out the point of inflection. So for this problem, I could not really write down the exact intervals because I really need to know the exact point of inflection. But what I'm trying to get you to understand still is the idea of concavity and concave up and concave down, what it looks like on a graph and how to know if you have a point of inflection. So here's another one. So if we start here, as we're going, what is it doing? Is it sort of opening up? Is it more like a bowl, or is it down? This is definitely concave up, right? Especially when you get down here, it's very obvious. So this whole thing is concave up. And as I'm going along, before I know it, here in the middle part of the graph, all of a sudden it's gone to concave down. So it's almost like it's definitely concave up here. By the time you get to here, it's definitely concave down. As I keep going, then next thing I know, when I get to here again, concave down, it's like an umbrella here in the middle. But then as I keep going, all of a sudden, next thing you know, it's curving up again, like a bowl. So it switched back and became concave up until the end. So what's happened? Concavity switched from concave up to concave down. I mean, somewhere in here, concavity switched. There has to be a point of inflection. Then here it's concave down. As I keep moving to the right, it became concave up. So here, so in this graph, there are 2 points of inflection. Once again, with the naked eye, we cannot pick out that precise point where it changes, but we will eventually be able to calculate that. All right, a few more of these just to sort of, once again, understand the concept of concavity. So here's one where we've got the function has like 3 parts to it. So we look at each part. So if I do this first part, what is this doing? Well, hopefully you can see that it's like concave up. It's like sort of one side of a bowl or a cup, right? So this whole thing is concave up. Then you jump to here. Actually, this whole middle part is concave down. And then this last part, as I'm going like this, what is this doing? Is this like a bowl or an umbrella? Well, this once again looks like the side of a bowl. So it must be. So this one actually, if you notice, there are no points of inflection. Now the concavity does change, but it's not part of a continuous function. There's a gap or a break here. So actually this one, we could give the intervals of an answer. You could say concave up is this part of it, which x is negative infinity to negative 1. And also this part is concave up, which starts at 1 and goes to infinity. Concave down is this middle part, and the value of x goes from negative 1 to 1. So it's concave down from negative 1 to 1. So it's this one, because there are no points of inflection, I was actually able to define the intervals. Here's this interesting looking graph again, which we got 2 parts. So if you start here, sometimes with these graphs, you can't really tell until you get more to the curve part of the graph. But once you get up here, you can see that this definitely looks like more like an umbrella. It's sort of opening down. So this definitely is concave down. But this actually has an asymptote, because you see the asymptote looks like it's right here, like at 1. Looks like there's an asymptote here. So there's a gap or a break. So once you get up here and you start along here moving to the right, then this looks like a bowl or a cup, this whole thing. So this would be concave up. So this one, once again, because there's no point of inflection, we can actually define the intervals. Concave up is this part here. It's like it starts at 1, and it goes to infinity. And then concave down starts here at negative infinity, and it goes to 1. The last one, another one, it's like 2 parts to the graph. It's like a point of inflection for this one is like probably like at x equals 2. So start along here, what we got going on, this looks like a concave down, actually this whole piece. You jump up here and you pick it up here, and it looks like it's probably concave up. So actually, I'm not going to take the time to write the intervals because we just sort of did it. Of course, the down would be negative infinity to 2, and then the concave up would be 2 to infinity. All right, so hopefully the key thing here was to just understand the concept of concavity, what it means when a graph is concave up and concave down, and when you have a point of inflection, even though on the graph you normally cannot actually define the exact point of inflection, but you know you've got one.